All right, never mind me too much. We're going to make a video here for anybody who's gone. So we're talking about exponential growth and logarithmic growth. Exponential has that type of a curve, whereas logarithmic has that type of a curve. And if we go into our statistics classroom, you can see here that we have 2021 exponential and logarithmic regression. Please go ahead and open that document. And as you open that document, go ahead and make a copy of it and save it for your own purposes. I think that I have a Chromebook charger borrowing it right now? Or is there another one? Oh, okay. Yeah, no, I was just trying to think of where I put that one. So I've got that one, I guess. If you want to borrow that one, you sure can. Okay, everybody got theirs open? All right, it says the following data shows the monthly mortgage payment and corresponding income. Determine if you should use linear, logarithmic, or exponential regression to model this data. Determine the R value, the best fit equation, and the expected income if the mortgage was $2,100. So the first thing we're going to do is we're just going to grab the data. And we would like to see if it's linear or exponential or logarithmic. I will even grab income and mortgage so we can see. I grab insert and I grab chart. And there it is. You look at it. Does it look like a line fits through it, or does it look like a curve fits through it? What do you think? I think a line fits through it pretty well, don't you? Sure seems like it's not perfect, but I bet if we used linear regression, I bet we come up with a line that fit this really, really well. Looks like I could draw a line just like that. Okay. So let's go ahead and use our linear regression option. We click here, and we go to Edit Chart. Customize. Do you remember where I go from Customize? I go to my series, and I go down to a trend line. Trend line fits on there, and then remember type. This is where we're going to change today. Linear, exponential, logarithmic. We are grabbing linear. Label, yes, we will use an equation, and we will show the R squared value. We can answer the questions right in here. The first question is, determine the R value. R is equal to, I have to take the square root of 0.948. Should my result be positive or negative? Positive, why? Because the line is trending upward. I get 0.974, so R is equal to 0.974. It also asks me to come up with a best fit line. It looks like income is on the bottom, mortgage is on the side. So I would say mortgage is equal to 0.405 times income plus 178. And then finally it says the expected income if the mortgage was $2,100. So do I plug the 2,100 in for M or for I? goes in for m. We'll carry it out up on the board here. $2,100 is equal to 0.405 times your income. Is it 178? Is that what we had? I'll solve that by subtracting the 178 from both sides. 2,100 minus 178, 192. Right, sorry, 1922. 0.405 times the income. Take that and divide it by 0.405, and you get $4,745.68. That's what we're looking at. Any questions on that first example? Flip to the next one. It says rabbits. Exponential. Let's, in order to determine whether or not it's really exponential, let's take a look at our curve. Let's go ahead and grab the data. Let us insert. And as we insert, we're going to insert a chart. And you can see there that it seems pretty obvious that the population stays low and then it gets pretty high. So I don't think that using a logarithmic regression or linear model would really fit this well. So as we try to fit a model for this, and this is where it is new for you, so please follow along, you're going to edit the chart. You will customize, and you will go to series. And as you are in series, you will select a trend line. And if you look, that trend line is absolutely horrible right now that you kind of put on there. If instead of linear, if you select exponential, label, yes, we are going to show the equation and we'll show our r² value. Now you can see how does that curve fit it compared to the line. It fits it extraordinarily well. That means it's going to be a better prediction model. So let's answer the questions then. The questions are as follows. I'm going to back out here so I can see better. So the following data shows a number of years and the rabbit population in a park reserve. Determine if you should linear, logarithmic, or exponential. We did. We said exponential. Also determine R value, best fit equation, and the expected rabbit population at 10 years. Okay, so we have the following. We have R is equal to, and we got to take the square root of 0.99. So square root of 0.99. And I get 0.995. So we're just going to go again with 0.99. Is 0.99 a good value? It sure is. Now we use our best fit equation. This is tough because we're not used to this. Rabbits is equal to, and it says 11 e raised to the, so use a caret key, 0.553x. Or instead of x, I'm going to write years. So this is where people struggle to come up with acceptable options of what to do here. Okay? It says the number of rabbits after 10 years. So I'm going to plug in 10 for that. And a lot of people aren't used to this. 11. And your E value, you can see on this calculator, is second natural log. So do you have an E button on your phone or something else? Here's what E is. You're kind of wondering what it is. If I press E and enter, I get 2.718. 2.718. Maybe we could try doing it without the use of your calculator. Would you like me to show you how to do this on just here so you don't have to grab your calculator? Here's what you do. We will make an equation. I think that this should work. I'm going to click on a cell and I'm going to press equals. I'm going to press 11. And instead of E, I'm going to write times. So times is shift 8. 2.718. And then we want to raise that to what? 0.553 times 10. Does that look right? Absolutely not, because you'd have to use your parentheses. I don't think that you're going to get this right unless you use a calculator. Somehow, you got to find a calculator on your phone or somewhere. Go to Desmos. You could go to Desmos and type it in. But if we just go 11 times, 11 times, I'm going to go E, and I'm going to raise E to the 0.553 times 10. If I just type that in, you can see I get 2,773.58, and that will be an accurate representation. Oh, sorry about that. 11.6. We'll be back here again. 11.6 times E raised to the 0.553 times 10. 11.6 definitely makes a difference. 2,924. I'm going to pause and make sure everybody has an option. Okay, our last option, flip over to bench press. So the following data shows the max bench press of an athlete and the corresponding number of years they've been weightlifting. Determine if you should use linear, logarithmic, or exponential. Determine the R value of the best fit equation and the expected bench press at year 8. So we've already talked about this. We would expect to be logarithmic. Let's graph it. So we're going to insert a chart. Does it look like it kind of plateaus off? It does. So some people might choose linear growth here because it does look like a line would fit that relatively well, but you have to think about the situation that's existing. We would expect that weightlifting would tend to plateau in that way. So we're going to go ahead and we're going to edit the chart. And when you go into your series, again, we want to put in a trend line. But instead of selecting linear, we select logarithmic. We're going to use an equation to fit and show that R squared value. I took the square root of 0.991 and I got 0.995. It appears that the equation is max bench equals 123 plus 58.7 times the natural log of x. ln stands for natural log. It's just the L comes before the N. That's because the word was originally in French. On our calculator, we can simply just type that in. 123 plus 58.7. And then you can see natural log is right where your E button was. Natural log, and we type in 8. And we had 245 pounds. As we finish up here, I want you to have a conversation with those around you. Do you think 245 fits the data or not? Do you think that there's a better estimate than 245? Let me know your thoughts. Take some time to talk. Go. That's the idea. That kind of finishes up. We think 245 might be a little bit high. Tomorrow we're going to gather together and we're going to look at the other couple, and you're going to work on that. I'll be ready to practice in class on Wednesday and be ready for a small test on Thursday. Okay, small test on Thursday using regression. So we'll refine your skills over the next couple days, and we'll get another good assessment in the book. So you guys can visit quietly.